Hello and welcome to the product rule. So the idea here is we've learned how to differentiate some functions, and we've learned how to differentiate when we add and subtract functions, but we have not yet learned how to differentiate when we multiply functions. But again, we've learned how to differentiate a variety of functions. Including sums and differences. But we have yet to see how to differentiate products. For example, if we had a function like f of x equals x squared times sine of x. We know how to differentiate x squared using the power rule. We know how to differentiate sine of x using our trig derivatives. But the product we have not yet seen. Right? So the product rule gives us a rule for differentiating products. So what the product rule says is if we wish to take the derivative of the function f of x times g of x, this is equivalent to taking the derivative of the first function, then multiplying by the second, so f prime of x times g of x, and then adding to that the first function times the derivative of the second. Okay, so this is the rule. So for the product rule, I'm going to actually go ahead and prove this. So the derivative of f of x times g of x. Well, to do that, we would take the limit as h goes to 0. Then first we would plug in x plus h. So we would have f of x plus h times g of x plus h. Then we would just plug in x. So we would subtract off f of x times g of x. And then that whole thing is divided by h. So what we're going to do is we're going to add in 0 in a strange form. So we're going to add 0 to the numerator. In the form f of x plus h times g of x minus f of x plus h times g of x. So if we do that, so here's what we started with. If we add that into the numerator, we wind up with a limit as h goes to 0 of f of x plus h times g of x plus h. Oops. Then I'm going to do plus f of x sorry, I'm going to actually do them in backwards form. Let's do negative f of x plus h plus. So now we'll subtract minus f of x plus h times g of x. Then we will add f of x plus h times g of x. And then we will subtract f of x times g of x. I apologize, that got a little squished. And that whole thing is divided by h. And then I'm going to group these terms and factor. Whoops. So I'm going to group these terms and factor. So if we group and factor, we have that this is equal to the limit as h goes to 0 of, let's go ahead and group those first two terms. And then we'll group the last two terms. So we have f of x plus h times g of x plus h minus f of x plus h times g of x. And then we have in the other group f of x plus h times g of x minus f of x times g of x. Again, I didn't give myself enough room. And that whole thing is divided by h. If we then factor out the common term from each group, we have the limit as h goes to 0 of that first group. We can factor out an f of x plus h. And then we are left with g of x plus h minus g of x. And then we have plus. Next, we can factor out a g of x. And we are left with f of x plus h minus f of x. And then the whole thing divided by h. From here, we're going to go ahead and split this. So now we're going to split into multiple limits. So first, we can split a fraction along its numerator. So we will rewrite this as the limit as h goes to 0 of f of x plus h times g of x plus h minus g of x, the g's in square brackets, all over h. And then we will add the limit as h goes to 0 of g of x times f of x plus h minus f of x all over h. Again, we can keep splitting. This is the limit as h goes to 0 of f of x plus h times the limit as h goes to 0 of g of x plus h minus g of x all over h. In the second limit, that g of x can just be pulled out front. It has no h involved. So then we have plus g of x times the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, if we pay attention to what we have here, This is just going to go to f of x as h goes to 0. This piece here is precisely the definition of the derivative. So that becomes times g prime of x. And then we have plus g of x times, again, this piece here is the definition of the derivative. So we have times f prime of x. And this is precisely our product rule. I just rewrote the terms in a slightly different order. So we could rearrange this as f prime of x times g of x plus f of x times g prime of x if we wished, swapping the order of the terms. So that is the product rule.